Hi, good morning everyone. So this is my first capstone project on solar power generation data. So in this project, I am presenting the findings of solar power generation data analysis. So in this presentation, I'll be finding out that I have gathered the this data from like two different solar power plants over a period of 34 days. So there are basically two plants, plant 1 and plant 2, and each plant has generation data and the weather sensor data. For the plant 1, there are the for the plant 1 in the generation data, the metrics are date time, plant ID, source key, daily AC power and DC power, and daily yield and total yield. Similarly, for the plant 1 weather sensor data, there are metrics like plant ID, ambient temperature, module temperature, which is the temperature around the surrounding environment and the equipment states, and irradiation, which is the sunlight that is received by the panels. So for this, I have imported my data using pandas and numpy, and I am representing my results in Mocha. First of all, I have uploaded my data, loaded my data, read my data using read underscore CSV, and after that, I started my data so that I can explore this data. First of all, the generation data for the plant 1 basically consists of 68788 entries and 7 columns that includes date time, plant ID, source key, DC power, AC power, daily yield and total yield. And there are no missing values were found in the data. So I have used pandas to read the CSV file and perform this basic approach operations using shape, info, head, tail, is NA for finding out the null values, the zero values, and describe so that I can find out the minimum, maximum values of the whole data, the mean, count, and standard deviation, and the percentile values respective to 25 percentile, 50 percentile, 75 percentile. Similarly, I did it for like the plant one weather data as well. And in the weather data, there are around 3182 entries and 6 columns. And the columns include date time, plant ID, source key, ambient temperature, module temperature, and irradiation. So let's start with exploring the data. Similarly, I have done it for like the plant 2 as well. In the plant 2, I have named it as DF2 generation, and for the weather data, I have named it as DF2 weather. Let's start with analyzing the data. For analyzing, first of all, I have converted my date time into a particular format, and the format that I kept it for my dataset is date, month, and year, and hour and minutes as a time. So the first exploration that I did is on the daily yield trends. So I examined the daily yield trend over the entire duration of the dataset, and I have observed the daily yield generally increases over time, which basically indicates a positive trends in the energy generation. So we can say that there is a consistent trend of increasing daily yield over the duration of the dataset. Next is I have calculated the daily production density per source. So my aim is to understand how power generation is distributed among different sources. So there are around 22 different sources in my datasets, and they are named by a source key which is unique. So my analysis basically revealed that there are varying levels of production density. See here, varying level of production density among different sources. So some sources exhibited the higher production density as compared to the others. Similarly, I have calculated the average daily and AC power. So in this case, my analysis find out the increasing average daily power over the time. So both AC power and the DC power shows a consistent upward trajectory throughout the dataset, which indicates the overall growth in power generation by the solar plants. Next, I have calculated the power production density, which examine the efficiency of the each source that converts our sunlight into electrical power. So in this case, on the x-axis, I have represented my 22 source keys, and on the y-axis, there is a AC and the DC power, which also suggests that there is a greater efficiency in the power generation as compared to the others. Here, my AC power is basically overlapping with the DC power, although it is representing both the details. So here I have represented the AC power per source and the DC power per source. See, these are the source name, and this is the AC power on each day. I mean on each date. Similarly, this is the DC power per source, different sources name and the their DC power. Next is I have calculated the temperature trends. So this in this basically I'm shifting my focus to the another dataset, that is a weather sensor dataset. So we have observed a correlation between ambient temperature and the module temperature, where the later one basically indicates the increase as the former rises, as we can see in this graph. So this basically relationship includes the influence of environmental conditions on the temperature of the solar panel. Similarly, I have calculated the relationship between ambient temperature versus the irradiation. So my analysis revealed a positive correlation between these two factors, with irradiation level increases as ambient temperature rises. So the impact of environmental condition on the amount of sunlight received by the solar panels. So in conclusion, we can say that my analysis for the solar power generation has provided invaluable insights, like in determining the performance and the efficiency of the solar plants. So we have identified that with there are certain trends such as daily yield, AC power, DC power, irradiation level, that basically shows a positive correlation between the potential areas for the optimization. So in this project, I have only did a visualization on plant 1. So in the future, I'll be doing for plant 2 as well. Although the data and the metrics are same, so I have like analyzed for only plant 1. So this is my first capstone project for the solar power data analysis that is done in India. Thank you so much.